going to use definitions and properties of trapezoids, isosceles trapezoids, and kites to try to find some missing parts in these quadrilaterals. So the shape that I have is just a trapezoid that's shown. I can't find the other two sides of this trapezoid based on that information alone. However, I can find some missing angles. This angle in the upper left-hand corner is a consecutive interior angle with the 60 because I do have parallel lines. That means these two angles should add up to equal 180 degrees. So that makes my upper left-hand angle to be 120 degrees. Very similar to that, my 10 degrees and my other missing angle are also supplementary because they're consecutive interior angles. Those are the only parts I can find in this quadrilateral. In my next trapezoid, I have some sides and segments that are marked. The only thing I know is that it's a trapezoid. I can't find any of the missing parts. There's no properties that tell me that opposite sides are congruent or diagonals bisect each other. There's nothing more I could find. Now, if I turn this shape into an isosceles trapezoid, I would be able to find a few more segments. The left side of the trapezoid would also be 5. And in an isosceles trapezoid, this will be true about the diagonal lines. They don't bisect each other. However, my lower segments and upper segments are the same. The way to view that is, if I drew a vertical line through this, I have symmetry on the left and right hand side. So those two triangles on the left and the right are congruent to each other. Now I'm going to take a look at the same isosceles trapezoid, but I gave two angles. We're going to see how many angles we can find in this picture. Keep in mind what was mentioned in the other screen. Those two segments should be the same in length. They're congruent to each other. These segments are also congruent to each other. That means in an isosceles trapezoid, you will always have two isosceles triangles. Knowing that I have an isosceles triangle, this would also be 40 degrees because these would be my base angles of that lower isosceles triangle. Now I can use the fact that the angle sum of any triangle is 180 degrees, which means this should be 100 degrees. Then I can find its vertical angle. I can get its linear pairs. And then last, I'm going to look at the top isosceles triangle. If my vertex angle is 100, that means each of these should be 40 degrees. Also, another way to get 40 degrees is to look at the fact that I have alternate interior angles between parallel lines. Now, as I mentioned before, this left and right hand triangle are congruent to each other. That means that this angle over here on the right should also be 20 degrees. Now I can use that the angle sum in any triangle is 180 degrees, so I can find my last two angles. Now we're going to take a look at this isosceles trapezoid. It is isosceles based on the markings, and there are two parts that I want to try to find. The one is segment AB, the one diagonal line. I know that this piece is 3, that is also a 3, and this would be a 12 because it's an isosceles trapezoid. So now I can find the length of AB using segment addition. So 112 plus 3. And next I need to find angle BCA. And I'm just going to mark where angle BCA is. I'm going to start with the 112 degrees. I can find its vertical angle. I can also find these two angles in this smaller triangle. Because this is an isosceles triangle, I can take 180, subtract off 112, which is 68. If I divide that in half, each of these should be 34 degrees apiece. Next, let's try to find this angle that's beside the 112. It forms a linear pair with the 112, so I'm going to subtract that from 180. That means this angle is 68. And its vertical is also a 68, if we want to find that. So now I'm going to take a look at this triangle. I have 15 and I have 68. If I add those together and subtract from 180, I should get 97 degrees as my missing angle. Now, my original objective was to find the measurement of angle BCA. I can use angle addition. I have 34 degrees and 97 degrees, which means my final angle should be 131 degrees. Now we're going to take a look at the kite. It is a kite by the markings of the sides. Picture's not drawn to scale, but I did give a few segments and I gave some angles. So I'm going to focus on the segments first of all. Something that's true about all kites. The diagonal lines are perpendicular. That means I will have 4 right angles where my point E is in this example. Also in this kite, I have these two sides, 4 and 5. I can use the Pythagorean Theorem to find the length from A to B. And I have the calculations in the upper left-hand side of the screen. So my length from A to B is approximately 6.4. I just rounded it to the nearest tenth, which means BC is also 6.4. Now I'm going to look at my lower triangles. The left side of this kite, BAD, is a reflection of BCD. That means E to C should also have a length of 4. Now I can find out how long ED is by using Pythagorean Theorem again. So I have my calculations here to the left. I need to subtract this time because I was given the hypotenuse to begin with. So based on my calculations, the length of ED should be 11.3. And because it's a kite, this segment is also a 12. So now I have all my segments marked, which means I can find the answers to my segments off to the right. Next, we're going to take the same picture. Now I'm going to focus just on the angles. Once again, the diagonal lines are perpendicular, so I have 4 right angles inside the triangle. If I use the angle sum of a triangle, that means I would have 20 degrees in this angle in the lower right-hand corner. I'm going to focus on triangle ACD. ACD is an isosceles triangle, which means this is also 70 degrees because it's a base angle in that isosceles triangle. I can also use triangle sum, and this makes 20 degrees for that lower left angle. Now to take a look at my angles BAC, and BCA. Now I'm going to focus on this triangle. This is also an isosceles triangle. The vertex of that triangle is labeled as 78 degrees. So if I subtract 78 from 180, and then I divide that by 2, each of these angles within that triangle should be 51 degrees. Two ways I can get the upper angles. One of them would be to use the angle sum in a triangle. The second way would be the fact that this angle is being bisected. There is one diagonal line in a kite that will bisect angles. So each of these smaller angles would be 39 degrees. So now that I have my angles in the picture, let's find our missing angles. Angle BAD. Angle BCE. The measurement of angle ABE. Angle CDE. Angle BAE, and our last angle is BEC, which is 90 because the diagonal lines are perpendicular. This quadrilateral is also a kite based on markings. So we're going to try to find as many missing parts as possible. So I'm going to start with the obvious ones. We can find those two sides right away. The next thing is, I have this information that AB equals 12. Each of these pieces would be 6, because there is one diagonal line that is bisected in a kite. Now if I were to perform the Pythagorean Theorem, which I can do because these should always be 90 degrees inside my kite, if I use the Pythagorean Theorem, I can find my missing sides. So I already did that calculation for you. I would have to subtract, because the hypotenuse is given. This piece would be 5.3 units long. And once again, I have the hypotenuse, so if I do 14 squared minus 6 squared, this segment is approximately 12.6 units long. So I can find all segments within this kite. Next I'm going to find the rest of my angles. I have 90 degrees inside. This angle is 13, so I can use the angle sum of a triangle, which makes this one 77. This large triangle is isosceles. This is also 77. Because I was given a full angle of being 100 degrees, I can just subtract the 77 from 100 to find this angle. And once again, I'm going to look at this triangle on the left-hand side of my kite. It is isosceles, so this is also 23 degrees. I'm going to use the angle sum for a triangle to find my last angles. So each of these would be 67 degrees. And I think the only angle I'm missing is over here, and the diagonal line bisects the angle, so these two are the same, or I could use the fact of angle sum of a triangle. Okay, my last shape is a kite where I need to find 3 missing angles. Because it's a kite, I have angle S as 125. These two angles are the same. I can use the fact that the angles in any quadrilateral add up to 360. By going through my algebra, I would find that x should equal 40. So if I substitute those in, my angle T is 40, angle R 70, and 125 for S.